how are we going to construct the frequency distribution table? For example, construct frequency distribution table using the scores of 30 grade 7 students in 30-item summative assessment in mathematics. Remember, these are raw data. And in organizing data, we have to put this inside the table. That's the role of the frequency distribution table. So let's construct the frequency distribution table given this data. These are the steps. First, determine the range, where range is equal to the highest score minus the lowest score. Second step is to determine the number of classes. We are going to use C equals 1 plus 3 the logarithm of n, where n is the number of population. Third step is to determine the class interval. In finding the class interval, we have to use this formula, range over the number of classes, or C. Now, let's solve the problem. First, let us determine the range. Now, take note that range is equal to the highest score minus the lowest score. The highest score based from the given data is 28. So, the highest score is equal to 28. And the lowest score is 8. So, by this, we have to subtract 8 from 28. So, 28 minus 8 is equal to 20. And that is the range. Second step, determine the number of classes. C is equal to 1 plus 3 the logarithm of n. Remember that n is equal to 30 and the logarithm of 30 is approximately equal to 1.4771. We can use scientific calculator to find the value of the logarithm of 30. To substitute, we have C is equal to 1 plus 3 times the logarithm of 30 is approximately equal to 1.4771. So let's multiply it by 3. We have 4.4313 plus 1 is of course 5.4313. Now, in this case, in this decimal form, we are always going to round up. So 5.4313 is equal to 6. Again, always round up. Even though it's just 5.1, it will still be equal to 6. So the number of classes is equal to 6. Third step is to determine the class interval. Now, the class interval is equal to range over the number of classes. A while ago, we have already the value of range as 20 and C, or the number of classes, is equal to 6. Let's divide them. We have I is equal to 20 divided by 6. 20 divided by 6 is equal to, or approximately equal to 3.3 or 3.3 bar. Again, always round up. So I will be equal to 4. So we already have the C as 6 and I as 4. Now, let's construct the frequency distribution table. But before that, we have to know where to start. To know where to start, multiply the number of classes C with the interval I. Then the result will be deducted from the number of items A. Then add 1 to the result. I have prepared already a formula for this. The start is equal to 1 plus the quantity A minus the product of C and I. Now remember that A, or the number of items, is equal to 30, C is equal to 6, and I is equal to 4. So by substitution, we have start is equal to 1 plus the quantity 30 minus the product of 6 and 4. Now 6 times 4 is 24, then deduct it or subtract it from 30, we have 6 plus 1 is 7. Therefore, the start is equal to 7. Start from 7, we have 7 to 10. Why 7 to 10? Because the interval is equal to 4. So if you're going to check 7, 8, 9, 10, the interval is equal to 4. Since there are 6 classes, there will be 6 rows here. So first class will be, or the bottom class will be 7 to 10, then the next will be 11 to 14, then 15 to 18, 19 to 22, 23 to 26, and 27 to 30. Now let's have the frequency for 27 to 30. So we have only one, we have 28. So the frequency is 1. For 23 to 26, we only have 25, so that's also 1. For 19 to 22, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10. For 15 to 18, we have 1, 2, 3, 4, 5, 6, 7, then 8. We have 8. For 11 to 14, we have 1, 2, 3, 4, 5, 6. So we have 6. For 7 to 10, we have 1, 2, 3, then 4. So we have 4. Now to check, it must be, or the total of the frequency must be equal to 30. Right? So that's how we construct the frequency distribution table.